Good morning everyone. Today we are going to see about state space representation of continuous time system. First, what is state variable approach? So it is a powerful tool or technique for the analysis and design of control system. The analysis and design we have following methods: linear system, non-linear system, time varying system, time invariant system, multiple input and multiple output system. So what are the drawbacks of transfer function? So before we had discussed a lot about transfer function, that is g of s equal to c of s divided by r of s with respect to the input and output we analyzed with transfer function. So in transfer function is defined under zero initial condition. Here it is applicable only for linear time variant and we have to restrict to single input and single output. It does not provide information regarding the internal state of the system. So this is the drawback of transfer function. Now we are going for state variable approach. So here we can apply any type of system and we with the initial condition and this also carried for multiple input and multiple output system, and it is not necessary to state the variables in physical quantities, and we can have predict the system in any instant of time. So this is the state space formulation. Here what is state variable? It describes a system at any time instant at the state variables. So here we are having three variables. First one is state variables. Its representation is x of t. Input variable is as representation as u of t. And output is represented as y of t. So we started with x1 or u1 or y1 up to n number of the state variables. This is the basic structure of state formulation. U of t represents the input side, y of t represents the output side, and here x1 of t, x2 of t are the state variables, where the state representation is going to have u as input, y as output, and x as a state variable. So this is a vector format where we can have the input vector, output vector, and state variable vector. So state equations representation. So dx of t. So what we have to do is, with respect to the vector analysis, dx1 of dt equal to dx1 dot and dx2 of t equal to x2 dot, and this x up to n number of variables we can have the definition in x3 of dot equal to f of t comma u of t. And for state model of linear system, here we consist of state equation and output equation with respect to the state variables. It is defined as x dot of t equal to f of x of t plus u of t. For linear time variant system and first deviation state variables, it can be expressed in the linear combination of the state variables. And this is the state model of the linear system where x1 dot equal to a11 x1 plus a12 x2 up to n number of for variables. So with this coefficient we can write the matrix form x1 of t, x2 of t up to xn of t into a into x1 t plus b and u of t the input value. And the state model system, the matrix equations can also written as x dot of t equal to a x of t plus b u of t, where x of t equal to state vector of the order and u of t equal to input vector of order and a equal to system matrix of order, b equal to input matrix of order. Now see this problem 1 with respect to state model. So here the mechanical system is represented here with respect to translation system. So here we have M1 are representation, K1, B1, M2 and K2 are represented here. You can see the first step is we are going for free body diagram M1. So here f of M1, B1 and K1 is connected. F of t equal to f of M1 plus B1 plus K1. F of t equal to M1 d square Y1 plus CT square plus b1 equal to d divided by dt, y1 minus y2, k1 equal to k1 minus v2, and f of t equal to m1 d square. So with respect to this we connected, and we had once again drawn the diagram for m2. So where m1 of m2, b2, v1, k2, k1 is connected in the diagram. So with respect to we have to write the equation form. Now we can choose the state variable x1, x2 and x3. So here f of t is represented as u of t, where x1 equal to y1, x2 equal to y2 and x3 equal to dy1 divided by dt, where x4 equal to dy2 divided by dt and x3 dot equal to d square y by dt square and x4 dot equal to d square y dt square. So substitute all this in the equations. that we can get u equal to m1 x3 of t plus b1 x3 minus b1 x4 plus k1 x1 minus k2 x4. So m1 replaced and x3 dot is replaced. So we have to identify x3 dot. So m1 is taken, being divided. Likewise, you can substitute the values for y1 equal to y2 and y2 equal to x2, y1 divided by dt equal to x3, then dy2 divided by dt equal to x4 and d square y1 divided by x4. So this we can substitute in equation 2 and identify x dot 4 and divided by m2. So here I am differentiating with respect to the dx1 divided by dt equal to dy1 divided by dt. We get the state variables functions. So according to that, x1 dot equal to x3 and x2 dot equal to x4. Then x3 already we calculated and x4 also calculated. Now write the matrix in the form of x dot equal to values of x1 where we got in x3. So 1 is represented in x3 and here in x4. So x4 is represented as 1, others represented as 0. Then x1, x2 values written from the equations x3 dot and x4 dot and the state variables, and 1 divided by m1 is our input variable. So this is the matrix form of y1 is equal to, so 1 0 0 where we have y1, then y2 is taken as 1, others will be 0. So this is the value of the value. So likewise we can exit this problem. Thank you.